Transformers are used everywhere in electronics, and it's a good idea to have a basic knowledge of how transformers function. So let's take a look at a simple wire, and if we were to add a battery to that wire, current would start to flow from the negative side to the positive side, and in doing so a magnetic field would start to expand from the wire. It's actually all over the wire. I'm only showing it in one small section here. Now when maximum current has been reached through the wire, the magnetic field stops expanding or stops moving. Let's start this over, but this time add a second wire close to the first one and a meter in the second wire to close the circuit, and I'm using this meter only to indicate current flow. Now the magnetic field cuts across the second wire and starts inducing a current in the second wire, and you can see that by the arrow and the meter, but notice that the current is in the opposite direction. And this will continue as long as the magnetic field is expanding, cutting across the second wire, or we could call that the secondary. When the magnetic field stops, then the current stops in the second wire, or the secondary. Now if we should lower the voltage on the first wire, or the primary, or if we would move the second wire away from the first wire, we would induce a current in the second wire, but notice now the direction has changed because the magnetic field is cutting across the wire in the opposite direction. And when we stop moving the wire, there is no current in the secondary. Now let's take a look at a coil of wire. And everything about the coil influences the characteristics of the coil. In other words, the number of turns, how they're wound, and the gauge of wire used all determine the characteristics of the coil. Now if we add a battery to this coil, again the magnetic field starts to expand, but it's stronger because of the coils of wire. But the same thing happens. It continues to expand until maximum current is reached and the magnetic field stops expanding. Now when we add another coil of wire, we'll call it the secondary, as the magnetic field expands, remember that it is stronger, it also cuts across more wire on the other side, transferring more power. But it acts exactly the same. The current is still in the opposite direction, and when the magnetic field stops, there is no current flow in the secondary. Now if we could instantly replace the battery with a wire in the primary, notice that the currents on both sides have reversed. And as the magnetic field decreases and then finally dissipates, there is no current flow again in the secondary of the transformer. Now one of the more interesting things about all of this is nobody really knows why this is. this is how it works. Here's a few examples of different types of transformers. Now the one that we've been using is this air core, and the primary and secondary are labeled. And the air core is mainly used in high frequency work such as RF radio frequency work. Here is an iron core. They're generally used in lower frequency like audio and power. They also, because of the iron core, can transfer much more power. In other words, that magnetic field is much stronger because of the iron core. Now here we have a step-down transformer. That's typically used in things like in the AM radios, the output transformer. About 90 volts on the primary side, and it's stepped down to high current, low ohms to drive an 8 ohm speaker on the secondary side. Here's a step-up transformer. Now the AC signal or power on the primary side gets stepped up because there's more turns of wire in the secondary. Now you don't get something for nothing. The voltage is higher, but the current is less. Now here we have an example of both a step-up and step-down transformer, which is very typical in your power transformers. I have made a air core transformer here. The green wire is the primary, which is the top trace, and the red wire is the secondary, which is the bottom trace. And the arrows here indicate that both coils have been wound in the same direction. Now if I should turn the secondary over, now they're wound in the opposite direction. It's in phase. Here they are in the same direction. Now they're out of phase, side by side. Now I'm going to put the secondary over the primary. When it's in that position, they're in phase. Now the turns are in the opposite direction. Now they're out of phase. So when you're rewinding coils, you really have to pay attention to how they wound that coil and reproduce it exactly. Of course, there's much more to transformers than this, but this is the basic information that I use all the time when I'm troubleshooting.